The optimal detector design problem can be considered as a multi-criterion problem, which is solved by these optimal problems. We need to minimize the detection probability, subject to these two constraints. The scalarization looks like this. This is a trace of a weighted matrix times the detection probability. So now we can transform the problems into these new problems, which is minimize the trace of the matrix equals to W times D. By using this formula, we can simplify these optimal problems, which looks like this. So now the original problem can be solved separately. So for every weight matrix W with positive off-diagonal elements, a deterministic detector can be obtained to minimize the weighted sum objectives. So at last we can get the estimator looks like this. The minimum mean square estimator, absolute value estimator, and map as the estimators for random parameter. A posterior distribution T and prior distribution Q are needed. So this is the way we find the map estimator. The mean probability of the error can be calculated by this formula. This is the definition of the weighted matrix. Then a base optimal detector can be given like this. So since the first term is independent with J, so the problems can be rewritten as this. Now I want to talk about the maximum likelihood. So when the prior distribution is a uniform distribution, map detector can reduces to maximum likelihood detector, which is this one. So now we need to know two things. First, for non-random parameter estimation, some estimators such as minimum mean square estimator becomes useless because the derivation depends on the prior and posterior distribution of the parameter theta. Second, the principle of maximum likelihood gives the value of theta, which is the most likely adjusted by the data X. So a maximum likelihood estimator minimizes the average error probability. So the last thing I want to talk about is the binary hypothesis testing. This is a big picture. First, we have two hypotheses on the source. The second, we need this probability transition mechanism, which is the probability distribution given the hypothesis. So this is the observation space, which is the data we collected. What we need to do is to find this lambda x, and we also need a threshold value eta. Comparing these two values lambda x and the threshold value, we can make the division. So now the detection matrix looks like this. So PFP means the false positive, which is we assume something to happen, but it doesn't. So PFM means the false negative, which is we assume an event doesn't happen, but it happens. So by using this detection matrix and using the same way like evaluate by using the Rix function in 1, which is this one. So we can find the solution.